This is a video on Ohm's law as part of the electricity topic for Year 9 Science. So Ohm's law was actually first proposed by a German mathematician and scientist named George Ohm in the early 18th century. And Ohm's law is what's known as an empirical law. Empirical means experimentally derived. Loosely speaking. So unlike in theoretical science or in maths where you can derive certain laws, certain formulas, Ohm's law comes from experiment, comes from many experiments conducted, and it was found quite simply that the voltage along a material like a wire is directly proportional to the current through the wire. It's one of the most simplest formulas in physics. V stands for voltage. It's measured in volts. It's got the symbol V for volts. I is current. A lot of students have asked me why not use C for current, because C has already been used in physics for the speed of light. And I is actually French. It was named after the French mathematician and physicist André Ampère in the 1820s, from the French intensité du courant, which basically means current intensity, to describe the flow of charge along a wire. Current is measured in amps or amperes. Amps is short for amperes, in honor of Ampère, the French mathematician and physicist. Amps, A for amps, and R is resistance. Units for resistance is the ohm, named in honor of George Ohm. And the symbol is a pair of legs. I like to call it a pair of legs, also known as omega, capital omega, a Greek letter from the Greek alphabet. It's a very simple relationship, V equals IR. Basically, if you increase the voltage along a wire, you essentially increase the current. Okay, voltage is like the pushing force. I like to think of it as like a hand pushing charge along a wire. Current is the flow of charge, typically electrons. And resistance is opposition to current. So you've got a hand pushing the charge along one direction, and you've got another hand opposing that current direction. Let's see how this works using some examples. So let's do an example here. Example 1, suppose I ask you to calculate the voltage through a resistor. Okay, a resistor is an electrical component which restricts current flow. And it's actually used quite commonly in circuits in your devices, because it's also a safety feature. It prevents heat up of the device and other things. Calculate the voltage through a resistor with resistance 10 ohms and current 1 amp flowing through it. So the first step in solving this, as always, is to write down what we're given, what we know. So what we're given is resistance. R is 10 ohms. So resistance R is 10 ohms. And we're given current I. That's 1 amp. And we need to work out V. Step 2, we need to write down the relevant formula. In this case, Ohm's law. V equals IR. We need to work out V. Step 3 is where we substitute, So we're simply putting our numbers into Ohm's law. V is equal to I, that's 1 amp, times R, which is 10 ohms. Without using a calculator, it's straightforward. 1 times 10 is 10, and the units for voltage is volts, so V. Make sure to write your units down. If you don't write your units down in an exam, you lose the mark for the answer. So let's suppose this is a 2-mark question. 1 mark for the working out, 1 mark for the answer. If you leave out the units in the answer, you'll get 1 out of 2, as opposed to 2 out of 2. So that's how Ohm's law works. Let's do another example. Suppose I ask you to calculate the current flowing through a motor if it has a resistance of 2 ohms and has a voltage of 12 volts applied. Okay, first step is to write down what we know. Now we're given the resistance R, which is 2 ohms, and we're given the voltage V, which is 12 volts, and we need to work out I, the current. Step 2, we need to use the relevant formula, Ohm's law, V equals IR. Now to find I, the assumption is that you know basic algebra here to make I the subject. I can do this in 2 ways. So for the mathematically inclined, to go from V equals IR to I, you would divide both sides of the equation by R. Okay, because whatever you do to one side of an equation, you have to do to the other side because of the equal sign. So the R's cancel out and you're left with the I, so therefore I is just V over R. And step 3 is to substitute in your known values. So I is V is 12 volts, 12 volts divided by resistance R. R is 2 ohms, 12 divided by 2 is 6, and the units for current is amps. That's one way to do it. Another way to do it is this. So start with V equals IR, and simply plug in your values. V is 12 volts, so 12 is equal to I, and the resistance is 2. I2, or 2I, just looks better written that way. So 2 times something is 12. I is simply 6. So the current flowing through the motor is 6 amps. Let's do another one. Example 3. Calculate the resistance for a light globe if it operates on 10 volts and has 5 amps of current flowing through it. Step 1 is to write down what we know. What we're given voltage, which is 10 volts, so V is 10 volts, current, which is 5 amps, I is 5, and we need to work out R. Step 2, write down what the relevant formula is, so it's Ohm's law, V equals IR. Then use the simple approach of solving this, so step 3 is to sub in. V is 10, so 10 is equal to I, which is 5, and R is the unknown. So 5 times something is 10, answer is 2. So therefore R is 2 ohms. And that's it. That's how you use Ohm's law. I've given 3 examples of how to work out V, I, and R. It's very straightforward. When you get the hang of it, you can probably even skip most of these steps and just do it in one step. But in an exam, it's important to show you working out as well as the answer. So that's not the end of the story. Now, Ohm's law, suppose you do an experiment where you change the voltage of, let's say, a power supply. Let's suppose we've got a power supply, or battery in this case, connected to a resistor. Zoom in. Okay, suppose I've got a table of values here. I'm not going to write down the numbers. Suppose I do an experiment where I've got a power supply connected to an ammeter and a resistor. And I want to work out how much current is flowing through the resistor for different values of voltage. So suppose I'm changing the knob, the dial on the power supply, the voltage V, I'm changing that. That's the independent variable. And I'm measuring the current, units of amps, using an ammeter. It's a very simple setup. Some wires, a power supply, an ammeter, and a resistor. The controlled variable in this case, the constant, I should mention, is the resistance. Resistance isn't changing. We're using the same resistor. In a table of values, the first column, the first heading, that corresponds to the independent variable. That's what you're changing in the experiment. That's the turning of the dial, the knob. Current is the dependent variable. That's what we're measuring. If I was to draw a graph of, let's suppose I had some numbers. Here's a graph here. Down here is voltage in volts and current up here in amps. Okay, remember the independent variable goes down on the x-axis. I'm down here. That's how I think of it. I for independent. And the current goes on the y-axis, the dependent variable. If you get a straight line, a linear trend, this device, the resistor, is known as an ohmic device, an ohmic component. Ohmic just means it satisfies Ohm's law. And I'll tell you why. V equals IR. V equals IR is actually a straight line when you sketch it. It corresponds to this. I'm going to rewrite this slightly in just a sec. Okay, think back to maths. You should have a basic understanding of things like straight lines and graphs. Y equals mx plus b. That's the equation of a straight line. It's a typical straight line. Y, that corresponds to the y-axis. Now, in just a moment, I'll show you why this makes sense. Just focus on the m for a sec. The m is the resistance. M is the gradient. Gradient means slope. Suppose I have a mountain like this and a mountain like this. The first mountain here has a higher gradient. It's much steeper than the mountain beneath it. So it's a measure of steepness, basically. And B, if you recall, is the y-intercept. Now, the y-intercept in this case is just the x-axis. Okay, it starts at the origin, 0, 0. Okay, that's the x value, that's the y value. Suppose I choose a point here, and I want to work out the gradient, the slope at that point. What would I do? So going back to maths, call this the run. Okay, think of running. You run along the ground, right? Not along the sky or across the sky. So run goes along the x-axis. This is called the rise. Think of a building that's a high rise. The building goes from top to bottom, bottom to top. So to work out the gradient, you simply do gradient m. You do rise divided by run. Now the rise in this case is the current. It's going to call it I. And the run is given by the voltage, which is V. We have an issue here because the gradient is so for an ohmic component, the gradient in this case is constant. Straight lines have the same gradient. At any point along the line here, the gradient's the same. But according to Ohm's law, to work out the gradient, which is R, if you recall, if you go back here, R is worked out using, I didn't write it down, that's okay. R is equal to V divided by I. But we have I divided by V. What do we do here? So to go from I divided by V to V divided by I, which is what we want, we simply take the inverse. Now I'm going to write it like this. From maths, if you recall, minus 1, right? To the minus 1. That means you invert it. You flip the bottom bit and the top bit of the fraction. The bottom bit's the denominator. The top bit's the numerator. So I over V becomes V over I. So to work out the gradient of this graph, you need to take the inverse, okay, the reciprocal of I over V. So that's how you calculate the gradient, the resistance in this case. You can't work out the resistance by using I divided by V. It doesn't make sense mathematically. Okay, Ohm's law is V equals IR. R is equal to V divided by I. So just be very careful. If you have the voltage on the y-axis and the current on the x-axis, no problem. You can do V divided by I. That's what you'll get, actually. So that's an ohmic component. I'm just going to sketch another graph quickly. If you have something like this, a curve, that's called a non-ohmic component. Okay, suppose you have another resistor and you measure its current, you get this graph. This is called non-ohmic. Why? Because the gradient is different at different points along the graph. Curves don't have constant gradient. They don't have the same gradient. They've got changing gradients. Okay. Now you can't also have a graph like this. There's no gradient there. There's no slope. Okay, so it's non-ohmic. It's not constant. Simply zero. You can't have something like this or like that, like a curve. You've got to have a straight line in order for the device to be ohmic. And that's Ohm's law in a nutshell.